Kia ora. In this chapter, we're looking at derivatives and differentiation rules. So firstly, in this video, we're looking at the differentiation of polynomials, which is something we covered last year. So if we're going to differentiate a polynomial term, we'll call it f of x is equal to ax to the power of n. So firstly, we're going to multiply the coefficient by the power. So that will be a times n. And then secondly, we're going to decrease that power by 1. So that means our derivative or gradient function or f dashed of x is going to be a n x to the power of n minus 1. If we had a function simply x to the power of n, then we know the coefficient is 1. So following that same process, our gradient function or derivative f dashed of x will equal nx to the power of n minus 1. So let's look at some examples. Example 1. Differentiate x to the power of 8. So we just bring that 8 down the front and reduce the power 8 by 1, so that gives us 8x to the power of 7. Example 2. Differentiate 4x squared plus 8x minus 3. So we're going to get 4 times 2 out the front, x to the power of 1, so that will give us 8x, and then we're going to have plus 8 times by 1 will just give us 8, x to the power of 0 just is going to be 1, so then we're going to get an answer like this. The negative 3 is a constant, and the shortcut we learnt last year is that basically it just disappears. The reason that disappears is because it's the same as negative 3 times x to the power of 0, and then if you were to follow that differentiation process, you're going to get 0 times negative 3, x to the power of negative 1, but you're timesing by 0, so that term just disappears. Example 3. Differentiate the function the x cubed, the fifth root of x cubed. So in this case here, what you want to do is you want to write it in index form. So we can write that, if you remember from last year, that the power lines go on the top and the roots of a tree go on the bottom. So we're writing that as x to the power of 3/5. And then following that process of differentiation, put that power out the front and then take 1 off that power. And if you go 3/5 minus 1, if that's a weakness, use your calculator. I've always said that. That gives us negative 2/5. Okay, and that is the correct answer, but it's good mathematical grammar to try and get it back into the same form that you've been given the question in. So what we could look to do is to put that x to the power of negative 2/5 on the bottom line, making that power positive, and then converting it back into third form. Okay, so that would give us 3 over 5 fifth root of x squared. Example 4. Differentiate the function 2 over x. So again, we want to write this in index form. So x to the power of 1 is on the bottom line. Let's bring it on the top line. So it becomes x to the power of negative 1. So then if we look to differentiate this, multiplying the negative 1 times 2 gives us negative 2, taking 1 off the power, making it more negative. So that's our answer. However, let's turn it back into the same format we were given, which had a positive index on the x term. So then we can just pop that x to the power of negative 2 on the bottom line, making it positive. So the correct answer for the derivative, negative 2 over x squared. And a little note there, just saying it's always good technique to do that. Example 5. So in this one, the function is 3x to the power of 4 plus x, all divided by x squared. So where possible, what you're trying to do is to see, can you simplify this before you actually look to differentiate? And in this case, we can, and we can do that by separating them into two fractions as one possibility. So if we split into separate fractions, that would just give us the function is equal to 3x to the power of 4 over x squared plus x over x squared. So just separating it down like that, and then look to simplify each fraction. So the first one would simplify down to 3x squared, and the second one would be x to the power of -1. So then we can differentiate at this point. So differentiating 3 times 2, we've got the 6, x to the power of 1, the second term there, bringing that -1 out the front, reducing that power by 1 gives us -x to the power of -2. And then again, getting it back into a nice fraction form, which is good mathematical grammar, gives us the gradient or derivative, or f dash of x is 6x minus 1 over x squared. So what I want you to do now is to try some of these. On page 263, exercise 15.01, and I think give them all a go. They don't take long, and I think it just really gets you familiar with those skills that we looked at last year. All right, good luck.